Okay, this video is going to be our first example for week 9's lab. In this we're going to be developing out the object we can see here. Now this object is a pentagonal based prism, as you can see. As well as that, it has actually a cylinder, a circle, extruded out through the center of the object here, as you can see in the elevation. And here on the plan you can see how it travels the whole way through the object, signified by this hidden detail here and here. Now what I'm going to do is I'm going to start developing it out. The easiest way for me to start developing this out is using my true lengths that I have here in my elevation and going out in this direction, seeing as that I have the space. So I'm going to take out the base, and I'm going to take out the top of the object, taking my heights. Then I'm going to decide a point at where I want to start it. I'm just going to keep it nice and close so I have plenty space here. Now I want to develop it out from, let's say, this corner around, starting here. So we'll call this 1/2, 3/4, 5/6, 7/8, 9/10. Okay, so we'll call this 1. Sorry, this is 1. This is 2. This is 9, this is 10, this is 7, this is 8, this is 3, this is 4, this is 5, and this is 6. Okay, now what I'm going to do is I'm actually going to break out that surface over here. I'm starting with 1 and 2, so this is going to be 1 and 2. Now I'm going to take out this surface here, so I can actually take my true length from here to here, because I know that I'm looking in elevation dead on perpendicularly, so it's going to be a true length. I can take that distance, 2 to 4, write that off. Now I have one of my surfaces here. Now what I'm missing from the center of that surface is the actual circle that's cut out of it. So I'm just going to find the center of the circle here. So now to move on to my next surface, so I'm going to be doing this one here. What I can do is take my true length from below in my plan, again here. Might as well knock them all off while I'm here. Surface of the next one, and then the last one. Now this is a nice and basic construction. Obviously the more complicated the shape is itself and the angles at which they're at, tougher it becomes, especially when you don't have true lengths percentage to the elevation plan. Then you have to do a rebatment to find the actual measurement itself. So let's see now what I need to do next. I need to have my circle here, which actually is one of the tougher parts of this, is because it is cutting out here on this side. It's going to be somewhat elongated for these two surfaces that are flat out. Now just to ensure that I'm working with the right surface, it's always important to number each of the sides as you have them numbered or annotated in the elevation and plan. So we have 5, 6, 7, 8, 9, 10, and then this is going to be back to 1 and 2 because these two join up. Now 78 is the center of the circle that's elongated. And now to find this, what we're going to do is we're going to divide up the circle with our 60/30. One side will be fine, we don't need to do both. Take them heights down into our plan. So, and now the distances from here, this point here to this point, to this point, to this point, are the distances we're going to need to step out. And you'll see how this circle is elongated, or it seems like it's a small bit squashed, as if spread out. Now we're going to be forming a small bit of a grid here. Now depending how complex the shape is, again, it might be important for you to label parts of the grid, especially when you're doing it out for students. Even this you would want to label just to ensure that you have everyone on board and no one's getting confused. Base first, it's going to be this point here, central point, and the next point up. It's going to be here and here. You can see already half the circle that we're going to be drawing. You can see that seems like it's nearly squashed downwards and pulled out. Now if you wanted, you don't even have to take these points across. You could just take the heights from here, swinging back, swinging back, swinging back. But for the sake of this, we might as well keep it consistent. There you go. There's your freehand curve. Hopefully you do a better job than that. Now what I'm going to do is I'm going to start outlining the actual perimeter of the development. Now the development is not yet finished, we have to do the top and bottom. So that's why I'm leaving one of the surfaces here light. As well as that, ensure that you indicate the bend lines. That'll just be with a dashed line, similar to what you're doing with your hidden detail. do is reform basically this shape itself. It's going to be the same size because this is a true length and true surface, a true shape of the surface, because we're looking straight down on top of it. As you can see here, it's an edge view in elevation, so we know that's the true shape below here in plan. So now we just have to recreate this down here. Do that, just take your distances, they're all going to be the same, like so. Now, I find the easiest just to do the compass method of drawing it. If you want to use a different method, that's absolutely fine. And then that is it completed. Just ensure the outline itself is dark. I'll have to go over this circle again, make sure that that's nice and dark to basically show the actual outline itself, and then all the lines that are bend lines, marks bend lines, as well as that. It's handy to mark in some annotations as well, like label this your development, label these your bend lines, label these your outlines, things like that. But this is a nice simple example of completing it. The toughest part of this was finding the actual shape itself here, as it's kind of elongated. Now, depending on the shape itself, it's more complicated and you don't have a true length in elevation plan, then you're going to have to do a thing called rebatment, which I'm going to do another video talking about how to use that to find the true length. That's usually when the questions get that bit tougher and get moved to that higher level.